The paper of the day is the Chubby log service for loosely coupled distributed systems. Chubby is a distributed log service intended for code-screen synchronization of activities within Google's distributed systems. It has found wider use as a name service and a repository for configuration information. Its design is based on a well-known ideas that have meshed well. Distributed consensus among a few replicas for fault tolerance, consistent client-side caching to reduce server load while retaining simple semantics, timely notification of updates, and a familiar file system interface. They use caching, protocol conversion servers, and a simple load adaptation to allow it to scale to tens of thousands of client processes per Chubby instance. They expect to scale it further via proxies and partitioning. Chubby has become Google's primary internal name service. It is a common rendezvous mechanism for systems such as MapReduce, the storage systems GFS, and Bigtable use Chubby to elect a primary from redundant replicas, and it is a standard repository for files that require high availability such as access control lists. Here are some of the key design decisions. One is coarse grain locking. Applications don't need locks for shorter durations. For example, electing a master is not a frequent event. Second, small data storing capabilities in addition to a log service, allowing thousands of clients to observe changes. So log service needs to scale to handle many clients, although the transaction rate may not be that high. Notification mechanism by which clients knows when the change occurs in a file that is shared when a primary changes. Basically. Support client-side sharing, client-side caching to deal with clients that may want to poll aggressively. Strong caching guarantees to simplify developer usage. Here are some of the highlights. Chubby is intended for use within a loosely coupled distributed system consisting of moderately large number of small machines connected by a high-speed network. The primary goals include reliability, availability to a moderately large set of clients, and easy to understand semantics. Throughput, storage capacity were considered secondary. Chubby's client interface is similar to that of a simple file systems that performs whole file reads and writes, augmented with advisory logs and with notification of various events such as file modification. Google File Systems uses a Chubby log to appoint a GFS master server, and Bigtable uses Chubby in several ways. That is, to elect a master, to allow the master to discover server it controls, and to permit clients to find a master. In addition, both GFS and Bigtable uses Chubby as a well-known and available location to store a small amount of metadata. In effect, they use Chubby as the root of their distributed data structures. Asynchronous consensus is solved by the Paxos protocol. Let's look at the contributions. This paper describes a log service named Chubby. It is intended for use within a loosely coupled distributed system consisting of moderately large number of small machines connected by a high-speed network. It's intended for coarse-grained synchronization of activities within a Google's distributed systems, and it has found wider use as a name service and repository for configuration information. Let's talk PS score for this paper. Overall, this paper is a pretty good read, so it gets 9 out of 10 on readability. It's 16 pages long. It scores 7 out of 10 on length. It's an analysis of an existing system with pretty good description, so that makes 9 out of 10. Its industry value and learning meter is pretty high, and it's widely adopted in production systems, so it gets 9 out of 10 on each, with overall PS score of 9 out of 10.